Good day and welcome to today's episode of Chemistry with John O. Now, quickly, I want to continue with the practical and calculations involved. But first, I want us to look at titration tables because these are aspects where students often make little mistakes. Now I'll be putting us through Waec standards according to marking guide instructions, things that drain your mark unknown to you. Now let's look at the table for a typical titration experiment. Now you have a 4 column and then there are 4 rows. 4 column 4 rows, including where you have your titles, making it 20 boxes or 20 squares. Now you have the titration, which follows as rough, first titer, second titer, and third titer. Now, one important thing you should note is always remember the units. The units. When this is not involved in your table, it is -1 and above. -1 and above. And please take note, drawing your table completely attracts 10 marks, including your average titer value, which I'll also be talking about. Now, the units I've talked about that. Then, neat table. Neat table also attracts your full marks. Now, in the situation whereby you are shading values, like maybe you have 5 and then you are shading, or you have a double line written on figure, it could be termed as malpractice, and then it could attract a penalty of -1. So try as much as possible to always write your pen once. Avoid shading the table. That is the point. And then another point where you might lose marks is when you don't follow concordant values. When you don't use a concordant, when you use 2 concordant or 3 concordant values, it attracts 2 marks. 2 marks. Yes. Now, what do I mean by concordant value? If you look at these values of volume of acid used, we assume that this experiment has been done and these are your respective titer values. Now, you have 24.50 centimeter cube for the rough. You have your first titer 24.7, 24.5, 24.6. Now, the concordant values here are the rough and second titer. The rough and second titer. Now, the one that is also closer to it that you could refer to as concordant will be this, 24.60. So these are points that helps you earn your full marks in titration tables. Now, coming to I've talked about not shading tables and values. Now, another point quickly is do not write with pencil. Do not write with pencil. Fine, you can draw your table with pencil, but make sure you write in ink. And then do not first of all write in pencil, then later trace it out with pen. There is a penalty of -2 according to Waec standard. Now I'm giving you this standard because by May 20th, Waec examination will commence, and then many students are void of this information. So please, if you are targeting A and B in your results for Waec as chemistry concerned, please, you have to take note of this important information in chemistry practical. Now let's move forward. Having said all that I've said, now your average titer value is going to be, the average titer value will be, if I've talked about concordant value, you can use 2 concordant values, and that will be 24.50 plus 24.50 over 2. Now this will give you an average of 24.50 centimeter cube. This is your Titre value. Now this is 2 marks. The table 8 marks. Now imagine if you are missing out your units, trying to shade using pencil, and then you are having -1, -2 at the end of the day, you might be left with just 3 marks instead of 8. And then if you miss out your average, your Titre average, it is also very dangerous. Now, the examiner might be looking out for your concordant value to give you full marks. If not, you can add up 3 values and divide by 3. I've often seen mistakes made by students each time I mark scripts, and I see that students will use 2 concordant value and go ahead to divide by 3. That is totally wrong. So please, let's take note of that as you prepare for your forthcoming examination. Now, having said that, you use your concordant value for a full mark, and then don't forget your units. Now, final reading of the table comes first. The final reading comes first, then followed by the initial. Initial usually zeros, depending, you use 0, and then always remember to 2 decimal places. 2 decimal places. There will be 2 decimal places, 2 figures after the decimal. It is very important. 2 figures after the decimal. If you use 1, instead of 70, you write just 7. Or probably instead of 01, you write just 1. It should be 10 or 01. So, or 00. It has to be 2 decimal. If it is not done that way, it might also be penalized. So please take note of those little. Now, if you are calculating your volume of acid used, it has to be final minus initial. Final minus initial. Now take note of this. You might not really pay attention to that. An examiner will calculate if your approximation, your calculation tallies or is accurate. Now, if it is not accurate, it might be suspected that malpractice was carried out, and it will be penalized on your scripts. It will be penalized. So always ensure that your final value, when you subtract initial, it must be equal to your volume of acid use. If your volume of acid use does not add up with your initial and final, then it is assumed to be an examination malpractice. Please, for Waec students, take note of this and work on them. So if you look at here, the titration gave 34.50, and then the initial is 10.0. This initial might be that your acid was at 10 mark. You didn't fill up to start from 0. This initial is usually that your burette is starting from 0 after you have loaded the burette. So if you continue from where you ended the first titration and you didn't load up your burette, then the value at which you ended the first titration in your volume of acid will be your next initial. Please take note of that aspect too. So, and on the long run, when you are subtracting your initial from final, you must have a hard up. Just take note of that. So, having said that, I hope you understood how to get your full mark in titration table, in drawing a perfect titration table. Now quickly we'll be going to the calculation. Now quickly, from the previous table we've seen earlier, now this is a typical question that could come during the main examination practical. Now the question says A is acid, so that is usually represented as acid A in question. A is 0.0950 mole per dm cube HCl. So the information is telling us that it is an acid-base titration because HCl is an acid. Then B is a solution containing 13.50 gram dm cube of X2CO3 decahydrates. That's 10H2O. That's decahydrates. That is an hydrated carbonate salt. Now, this is not given what element is here, but we are less concerned. What the question says is what we work with, and then we calculate. Now, pipette information is 25 centimeter cube or 20 centimeter cube. Usually, oftentimes we use 25 centimeter cube of base. That's the volume of base used. Now, the question is from your results and the information provided. Now, these are information, concentration of acid. This is it in mole per dm cube. So, you also have to take note of units. Units gives you more information. Gram, mole per dm cube. We have gram per dm cube. We also have gram per mole. Now, from your results and information provided above, calculate one. Concentration of B. B is talking about the base used, which is a carbonated hydrated salt or hydrated carbonated salt. So, concentration of B in mole per dm cube. In mole per dm cube. Then the second question says the molar mass of X2CO3 decahydrates in gram per mole. Then the third one says percentage by mass of X in X2CO3 decahydrates. Now, step by step please pay attention as we go through the calculation process here. So from question 1, let's calculate first the concentration of B in mole per dm cube. Concentration of B. Now, before this, let's look at the information provided from the question earlier on. We have concentration of acid to be 0.0950. Don't forget the unit, that it is a mole per dm cube. Mole per dm. Then what other information do we have from the question? We have B is a solution containing 13.50 gram per dm cube of X2CO3 decahydrate 10H2O. Now, what other information we have? Pipette is 25. Volume of base, that's the volume of pipettes used. And then what other information? Now, because we want to calculate here, now mind you, we also have the equation of the reaction. That is also very important to what we are doing here. Equation of the reaction says we have 2HCl, written that this information we'll be working with now. Concentration of base in mole per dm cube. What do we have to look out for first? That is the concentration of the formula given. We have CAVA. I always tell my students, always define your formula, then find out what do you have, what do you need, and what are you looking for. Now, CAVA over CBVB equals to Na over Nb. Of course, concentration of acid, volume of acid used, concentration of base, then volume of base, number of mole of acid, and then number of mole of base. So in this case, what is our volume of acid? Volume of acid is our Titre value from what we have. So, and it is 24.50 centimeter cube. Let's take note of all this information. Then we are going to be needing it here. Now, from the question 1, what we are looking for now is Cb, concentration of base. So, basically, do we have concentration of acid? Yes. Do we have volume of acid? Yes. Do we have concentration of base? No, that's what we are looking for. Do we have volume of base? Yes. That's the volume of the pipette. Do we have number of mole of acid? Yes. The number of mole of acid is found in the equation. We have 2 moles. Number of mole of base? Yes. It is 1 in the equation given. So, here we are good to go. We are halfway done. Making Cb subject of formula here, then we have what with CbVb Na equals to Ca Va and Nb. So you divide through to eliminate what is disturbing. That's Vb Na Vb Na. So this cancel out. So our concentration of base now, Cb equals to Ca Va Nb over Vb Na. Now, with this, we are done solving. We just insert the values of what we have. And here, the values will be given as concentration of acid gives 0.0950 times volume of acid 24.50 times number of mole of base 1 over volume of base is 25 times number of mole of acid, that's 2. So here we have 2.3275 over 50. 25 times 2. So let's divide this by 50. So we have 0.046. Now it is always good to 3 decimal places. Mind you, your unit mole per dm cube. Now during marking, this unit is very important. If you have a correct value but a wrong unit, then it is very dangerous. You miss it out. You lose a mark for that. It is better if you don't remember the unit, but the title of the question has saved you that you are working under mole per dm cube. So you may not bother to put it. But if you must put the unit, then it must be the correct one so that you don't lose a mark. So that is the concentration of base in mole per dm cube. We have 0.046 mole per dm cube. And that is what we have for our Cb. Let's note it down. So Cb is 0.046 mole per dm cube. Now, because we are still going with my Cb needing this, so let's note it while we move to the next question quickly. So the question 2 says X2CO3 decahydrate. So this is our next calculation. Now, how do we find the molar mass? First of all, you must know the formula for molar mass. Now, the formula for molar mass, we have number of mole equals to reacting mass over molar mass. We can use this formula. Number of mole equals to reacting mass over molar mass. Mind you, molar mass of what are we looking for? Molar mass of base. So if you are calculating the molar mass and the number of mole, it must be that of base, not that of acid. Let's take note of that. Now, coming here for the molar mass of this, mind you, we're not given X. We're not given this. So we just have to ignore. We cannot assume we know what S is. So we just solve out our molar mass from this. And how do we go about that? What is the number of mole of base? In our calculation, we have this 0.4. So we have 0.046 mole per dm cube equals to reacting mass. Mind you, from the question we're provided that this contains 13.50 gram of this. So those are the information we're provided with. So our reacting mass is 13.50. Understanding the unit, gram per dm cube, the unit helps you know that this is a solid. It is a mass reacting in the solution. So we have 13.50 gram per mole over molar mass. Now molar mass is what we are looking for now. So we make molar mass the subject of the formula. From here we have 0.046 times molar mass equals to 13.50. So we divide through by 0.46. So this cancel out this. So our molar mass we are left with equals to 293.47. 293.47 gram per mole. Gram per mole. Take note of the unit, as this is often very important to your accuracy. Now, having said this, we have arrived at the second question. This is the molar mass. Let's also take note of this molar mass because it will also be needed. So, question 2, molar mass equals to 293.47 gram per mole. Are we following? Then we move quickly to the third question for Waec student to take note of all these little mistakes during chemistry practical exams, as they may reduce your mark unknown to you, especially 3 decimal places, 3 significant figures, correct units, and then the approximations. Now, Roman figure 3. The question says the percentage by mass hydrates S2CO3 decahydrates. Now, to find out what this is, we must first of all find the value of X. We must first of all find the value of X. Then we can now find out what is the percentage. But without knowing what S is, we might not be able to find out that. But let's just quickly, what is the percentage? Percentage is the pure over impure. Pure substance over impure. Now, in the question, we have molar mass. Yes, this is the correct molar mass. So let's find out what we have here. Then we can now check out. So we say X, the molar mass of X, times 2 plus carbon is 12 plus oxygen times 3. Oxygen is 16 times 3. Then we have water, that's 18. Water is 18, that's 18 times 10. We have 180, if I'm not wrong, plus 180. So, adding up those that are similar, we have 2x plus 16 times 3, that's 48. 48 plus 12, that gives us 60. Yes, 48 plus 12, that's 60. 60 plus 180. 60 plus 180, this is 240. So we have 2x plus 240 all equals to the molar mass of the salt. The whole total mass is this, which is 293.47 gram per mole. Now if we have this, we are looking for S. So here we are going to collect like times to see what we have. So 2x will be equals to 293. Let's approximate, or leave it that way. Let's just approximate. 293.5. 293.5 minus 240. So let's see what we have. So we have 53.47. This gives us 53. 2s equals to 53.48. 53.48. So looking for s, we divide both sides by 2. So 53.48 divided by 2, 26.7 equals to 26.7. This is x. 26.7. This is for x. So having this as the value of x, mind you, we are looking for the percentage of x, percentage by mass of x. So if x is 26.7, then we are having x2. That means this multiplied by 2, which will still give us what we had here, 2x. So let's quickly check out what we are going to get there. 93, the molar mass, 293, the molar mass, that's 293.47 over the mass of x times 100. So x is this times 2. We have x is 2, so we are going to have 26.7 times 2. 26.7 times 2. 26.7 times 2 over the overall molar mass that we got earlier. Are you following? Times 100%. So let's, we have 0.182 times 100. Have 18.2%. Therefore, the percentage by mass of x in this whole compound is 18.2%. In the next video, we'll be looking at other similar questions, but not exactly, that might be talking about atoms, how much of atoms or particle present in either the base or acid used. The number of mole of atoms, the number of mole of ions, we'll be looking at how to calculate that. Please stay tuned with me, and then